Welcome back, Primary 6. Let's move on Unit 2. Today we want to discuss Lesson 3. We studied before the meaning of a proportion, also the properties of a proportion. Today we will discuss the drawing scale. We want to know what is drawing scale and how to calculate drawing scale. Okay, what does the drawing scale mean? What do we mean by drawing scale? Let's look here. This is the map of Egypt. Of course, the distance here, any distance here is not real because Egypt is huge and the distance are measured by kilometer, but here it's small and the distance are centimeters. So there is a ratio between the real length and the drawing length. The length here and the real length of Egypt, or the area of Egypt and the area here and the map. Okay, they are not the same. So we should take a ratio between them to get accurate map. So the drawing scale is the ratio between the drawing length and the real length. Okay, so what is the drawing scale? It's the ratio between the drawing length, the length here on the map, and the real length. Okay, when we calculate the drawing scale can be greater than 1 or it also can be less than 1. If the drawing scale is greater than 1, it means I enlarge the object. For example, as if we draw a picture for an insect, the insect is so small, I want to enlarge the picture, enlarge this insect on the picture. So this is enlargement or magnification. Okay, so the first case, if the drawing scale is greater than 1, it means that we enlarge the object. The drawing scale also can be less than 1. In this case, we call it reduction or minimization. Okay, minimizing or reduction. Okay. We'll study now the relation between drawing length. This is drawing length. It means the length on the map or in the picture. Also, we have drawing scale. It's the ratio between the drawing length and the real length. DS denoted DS means drawing scale. DL drawing length. RL means the real length. Look at this triangle. It's very easy to get drawing length. Drawing length here equal drawing scale times real length. Drawing scale, drawing length over real length, and the real length equal drawing length over drawing scale. Okay, this triangle is very important. I hope you have understand it well. Let's take some examples. Example number 1, here we have the drawing scale of a map is 1 to 400,000. This is the drawing scale. If the distance between two cities is 46 kilometers, we have a distance between two cities, 46 kilometers. Is that the real length or the drawing length? I want to find the distance between them on this map. Okay. Let's read the example again. The drawing scale of a map is 1 to 400,000. It means this is the drawing scale. The distance here, 46 kilometers, this is the real distance. Okay, so the real distance or the real length is 46 kilometers. I want to find the distance between them on this map. Okay, the distance on the map, of course, will be by centimeters. So I'll change the drawing length here. I don't know the drawing length, but I know that the drawing length equal real length times drawing scale. We have the drawing scale, we have the real length, but we will not multiply before we change 46 kilometers to centimeters by multiplying 100,000. So I multiply 46 kilometers by 100,000 equal 4,600,000 centimeters. Okay. Now drawing length equal real length times drawing scale. Real length here and the drawing scale 1 over 400,000. The result will be 11.5 centimeters. Okay, so the distance between the two cities on the map is 11.5 centimeters. Example number 2. If the distance between two cities on the map is 3 centimeters and the real distance between them is 9 kilometers, what is the drawing scale of this map? Here we have the distance on a map. So this is the drawing length. 3 is the drawing length. Also we have a real length which is 9 kilometers. But of course we should convert to the same unit. Okay, so 9 kilometers equal 900,000 centimeters. Now drawing scale, as we mentioned before, equal drawing length over real length. And then we should simplify. Here we have drawing length is 3, real length is 900,000, and then simplify, it will be 1 to 300,000. This is the drawing scale. Okay, let's move to example number 3. The opposite figure shows the floor plan of a house with a drawing scale 1 to 150. So here we have floor plan for a house. The drawing scale here is 1 to 150. As you can see on this picture, we have length and width for all rooms in this flat or in this floor. The required is to find, number 1, the real dimensions of the living room. Where is the living room? Yes, here. And the real area of the house. Okay, let's start. Don't forget the drawing scale is 1 to 150. I want the real dimensions of the living room. This is the living room. Okay, the real length equal drawing length over drawing scale. The drawing scale here is 1 to 150. Okay, so we have length and width. This is the living room. The length is 3.6. So I'll divide 3.6 divided by 1 over 150 to get the real length of the living room. It will be 5.4 meters. This is number 1. Okay, I want now to get the real width. Where is the width? Look at here, the living room, the width is the same as here, 2.4 centimeters. So by the same way, I'll calculate the real width. 2.4 times divided by 100 over 150. So the real width is 360 centimeters. It means 3.6 meters. Okay, so this is A, the real dimension of living room. What about the area of the house? We should calculate the real length and width of this department. Then we can calculate the area. Okay, the real length of the house, look at here, we have 2.6, or from here it's very easy, 3.6 plus 2.6 plus 2.6. Okay, look at this line. This is the length of the house, 3.6 plus 2.6 plus 2.6. Okay, but this is the drawing length. I want the real length, so divide by 100. Divide by drawing scale, which is 1 over 150. it will be 13.2 meters. What about the real width? The width here is 2.4 plus 3.4. So the real width 2.4 plus 3.4 also divided by 1 over 150. It will be 8.7 meters. So the real length is 13.2. The real width is 8.7. Can we calculate the area? Yes, of course. The area is like an area of rectangle, length by width. So the area will be 114.84 meter, and don't forget meter squared, because this is area, not a length. Okay, I hope you have understand our lesson today. It's very interesting lesson. Please try to solve it yourself again. All the examples we have solved, try to solve them again yourself. Thank you very much. Last session we will discuss proportional division. Thank you very much for listening.